deal with, we are going to look at what are called numerical summaries. But let's take a step back before we get too caught up in the forest. Imagine that you've collected your data and you like it, it's good data. One of the things that you do typically after that is you try and visualize it. And that's when you do things like you make it into histograms or pie charts or scattered plots or whatever it might be. And the other thing that you very often like to do with it is to summarize it. And that's what we're going to look at today. We are going to look at two major types of summarizing. The first one summarizes, well, there are different textbooks call it different things. We're going to summarize location is one of the names they use for it, or typical value is a better term. So we're going to look for the typical value in that data. What's the guy in the middle, the typical number look like? And we're going to look at numbers that measure spread. The spread is basically a number that tells you how spread out the data is. Now, the summary ones that we're going to look at, for instance, the first group are mean, mode, and median. And these three are just numbers that tell you the typical value. So if I collected the ages of 200 students who took statistics, I might say, well, what's the typical age of a student? Are they all quite old? Are they in their 40s, most of them? Are they in their 20s? Are they in their teens? And mean, mode, and median do that job. The one that you would probably call the average is actually called the mean. And in fact, the word average is actually used for all of these. So we would say location, typical value, or average would be another term. So the word average could mean any of these. If you want to add them all up and divide by how many, we call that the mean, right? And we have mode and we have median. And then we move on to things called 5-figure summaries. And from there, we can look at how to visualize the data using things called box plots. So let me take some data and just some random data. And let's suppose I collected the ages of 10 students who were in our stats class. In fact, I'm not going to collect 10 students and just write down numbers. If you go to chat and you want to take part, type in your age. Just type in 42, 17, 12, 80, whatever it is. And I will take those numbers as they come. All right. So this will actually be real data. Okay, so these are the numbers I am looking at: 16, 18, 18, 17, 18, 18, 16, 19, starting a new row now, 26, 19, 24, 17. Right, that's it. Voting is over. So here is my raw data. And I want to work with this data. In particular, I want to get some idea of what a typical statistics class at Olympic College looks like. And so I'm going to make an assumption that you lot are pretty typical statistics students, right? There's nothing remarkable about you. But one of the things I might do with this data, just to make it more manageable, would be to put it in order. So 16, 16. So 16, 16. There's a 17 and a 17. Okay. change colour because I want to. 18, 18, 18, 18. So there are 4 18s. We've got a couple of 19s. And what do we have? A 24 and a 26. So would you agree it wasn't a big deal, but putting everybody's age in order, didn't that help you get a better idea of the ages of the people in this class, right? Let's look at the extremes. Youngest, 16, oldest, 26. Right? So far, so good. Right? Now, let's calculate the mean. The mean is what you get when you add them all up and you divide by how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. So N on the bottom, and I'll put the word total of numbers on the top. So it's like a little formula. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just double check on that. N equals 12. We like to use N to represent how much is in the data. So all I'm going to do right now is add up all those different ages. So here we go. Add those together. Add those together. 1, 2, 3, 4. Add those together. Add those together. Add those two guys together. It looks like I get 226 divided by 12. And we will get a mean of 18.83. So I'm going to do it to 1 decimal place. And there is the mean. And you'll sometimes see in textbook that the mean is written as an X with a line above it, and you call that X bar. So X bar is just another name for the mean. In this case, it's 18.8. So my summary says that a kind of typical age for a person in this class is about 18. Would you all agree that that seems reasonable? Yeah, there's a lot of 18s. It's not, I hope, a surprise to you that the answer is a decimal, right? There isn't anybody in this class, I suspect, who's 18.8 years old. Most people don't count their age that way anyway, right? You're 18 and then you're 19, right? You don't say, unless you're a kid, I'm 4.5, right? Kids like to put in the extra 6 months because they want to be older, I guess. So it's okay for the mean not to be that value. That's why you can have the average number of children in a typical American family is 2.2 children. That's an interesting summary, right? The average number of children in an American family is 2.2 children. Now, if you think about it, it doesn't mean that every family has 2 children and a head. I'm not even sure what 0.2 would be, right? Isn't it just a number that says it's round about 2, maybe 3? Does it mean everybody's got 2 and 3? No, because isn't this mean of 18.8? Aren't there some 16s and aren't there some as big as 26? But roughly in the middle, right? The typical guy in the middle is about 18-ish. And that's what a summary does. It's not trying to tell you, oh, everybody is this age. They're just trying to tell you the typical guy in the middle's that age. Now, the second one in this list is called the mode. Not as helpful. I don't like the mode, but we're putting it in for completeness. And the most common, in this case, age, is the mode. And would you agree that in this case, there are more 18-year-olds than any other age group, right? There are 4 18-year-olds in this class, and so the mode is 18. And I think in this particular situation, the mode is quite a good judge of who, who the typical age of a person in this class is. Now, the third and final one is called the median. And the median is a pain in the butt to calculate. It just is. I mean, that the mean isn't great, but you know, it's just long, right? You can add up a lot of numbers and get the mean, but even that becomes cumbersome. If I went and said to you that I got 200 OC students who took statistics, you really don't want to add up 200 numbers, agreed? You don't want to do that. Just forget it. It's too much work. But, you know, it's a good summary if we can. The median is even worse than that. The median is the middle number when the data is in order. So there are 12 people in this class. That means guy number 6, right? Half of 12 people is 6 people. Guy number 6 is the median. So counting from this side, you're number 1, you're number 2, you're 3, you're 4, you're 5, you're 6. You are guy number 6. But if you count from this side, you're 1, you're 2, you're number 3, you're number 4, you're number 5, you're number 6. Well, we got lucky here, didn't we? Because although there's 2 numbers in the middle, aren't they both the same number? And that number is 18, right? So in this case, the median is also 18. Can we pretend in a different class, right, with a different number of people in it, whatever you want, we got 21 and a whole load of guys going this way, and 24 and a whole load of guys going that way. And the 2 middle numbers were these 2, right? You might say, well, all you do is you write down both. You just say the medians are 21 to 24. That's not how we get around that problem. We need a single number to represent the median. What do you think you would do if that had happened? What single number would you use to represent the typical guy in the middle? And by the way, guy to me means male or female, it's generic. Typical guy in the middle.
Didn't you find the mean for those 2 numbers, adding them together and divided by 2?
Exactly. So it's a bit messy, isn't it? But it's what you do. It's 45 divided by 2. And that's what, 22.5. So that's what the median would be. Now we can do that with relatively small data sets, right? As long as you've got 8 people, 12 people, 15, 17, 19 people, you can get the median, right? It's a pain in the butt, but you can do it. But you've got to also remember, won't the chances be that the data is all jumbled up like it was here? So won't your first job be to put them in order before you can even figure out who to pick in the middle? And so what I want to do is show you a trick that you can do that lets your calculator, your TI-84 calculator, do the job for you. Now, if you don't have a TI-84 calculator, the college will allow you to borrow one from them. So go down to the mesh office in building 8, talk to, I think it's Cheryl, and say to Cheryl, you'd like to get a loaner of a TI-84. I think all you do is show some proof of identification, and you can get it for the quarter and it'll be free, right? So it won't charge you a bit, you just make sure you bring it back at the end. So I'm now going to show you how to find the mean and the median using your calculator. And this is very helpful when you have got like, oh, I don't know, 20 numbers, right? Or you've got lots of numbers and you just don't want to do it, right? So let's see how that works. So are you looking at a TI-84 emulator right now? Somebody say yes, please.
Yes, we are.
Okay, so we are ready to rock and roll. So first button, that button there called Start. Press Start. Option 1, Edit. Press Edit. And you are going to type into this column all the ages or whatever the data might be. So I'm going to put them exactly as I started life with, right? So it was a 16, then it was an 18, then another 18. It was a 17, and then it was 2 more 18s. Then it was a 16. This is the longest part of the whole thing, just typing in the data. But trust me, if you had 30 numbers to do, typing in 30 numbers is a lot less work than trying to put 30 numbers in order and writing them down again, right? So there we go. So remind you what I did, hit Start button, press option 1, Edit, type in your numbers, okay? Right, that's the hard part over. Now, hit Start button again, move by using this cursor over to the calc, and you see there's a guy called One Variable Stats. Press Enter. Now, in my calculator, the list is L1, so all I do is hit a whole load of enters. Now, can you remember that mean that I got of 18.83? There it's there for you. You see it's called X bar. If I scroll down a little bit further, can you see the median is 18? That's it. Everything you want and some stuff right now that you don't want is given inside that one menu. And in my opinion, that is a lot, it saves you a lot of grief, a lot of work. So get a hold of a TI-84, beat up your little brother, steal it from him, go down to Cheryl, get a loaner, whatever it takes, and you are good to go. Okay, let's pause here. Are there any questions so far?
Yes, sir. You said the TI-84 calculator we can get in building 8 from Cheryl.
Yeah.
Did you specify where in that building?
If you walk in want of a better word, do you know the front door of building 8? It's facing the library. You walk in the front door, and on your left-hand side is the mesh office. So you'll find it in there.
Okay, thank you, sir.
Okay, now let's look at what does that, what do the questions in the homework look like based on what we've just done. So again, I'm assuming that you're all looking at WebAssign right now. Is that what you can see?
Yep. Yes,
Great.
sir.
So let's scroll down to, or up, wherever it is, to our class. And there we go, 146. I'm going to put this in student view, that way it looks more what you would see rather than what I see. There we go. So, blah, blah, blah. Go away. Right, so numerical summaries, what we're on right now. Let's click on that. So the height in inches of 7 adults are given here. Find the median height and then find the mean height. Now, couldn't you do them both by hand? Or couldn't you do them with the TI-84? Great. Now, if I wanted to find the mean of these 1, 2, 3, 4, 5, 6, 7 numbers, wouldn't I just add them all up and divide by 7 and round off the answer to 2 decimal places? Does that seem pretty obvious what you're being asked to do? Great. Now,
Yep.
suppose I wanted to do the median. Wouldn't I have to rewrite these numbers in order first and then figure out the answer? So I could do that on the TI-84, but not everybody's going to have it or like using it. So if you can bear with me for a few minutes, I'm just going to write down 65, 66, 67, 68, 70, 71, and 72. 1, 2, 3, 4, 5, 6, 7. Right. So if I wanted to do this question by hand, because I don't like calculators unless I need them, right? There is that data set in order. There are 7 numbers in that data set. So we have to pick the middle person. So actually, it's a little bit easier when there's 7 or 11 or any odd number like 31 people, because the middle number, or the middle position, I really should call it, is 7 add 1 divided by 2. In other words, it's the 4th number. So 1, 2, 3, 4 takes you to there, right? 1, 2, 3, 4. From this side, 1, 2, 3, 4. Do you see they end up being the same place? So in this case, your median is 68. Now, when you might have problems is when there is an even amount of data. Let's say there's 6 numbers. Let's say it was 17, 19, 21, 23, 23, 40, right? Now, when there's 6 numbers, you divide that by 2 and you get 3. 1, 2, 3, that guy. But if you count in from the other side, 1, 2, 3, it's that guy. Do you see that you get a shared 2 guys in the middle? And we know how to deal with that. The median would be just the average of those 2. The median would be 22. Are we okay with how you could do that by hand, or you could do it by doing it on the calculator? Do you want me to do one of those data sets using the calculator just to see how it works again? Yes, no, I don't mind. If you want me to do it, a thumbs up, we'll get it. Okay. So if you bear with me for a few seconds, I will set it up and show you what we need to do then. Okay, there's the thing on. Okay, now I'm going to go set and quit. Now, this is going to cause an issue, and that's okay to cause an issue. I'm going to go start, I'm going to go edit. And if you've done your calculator, isn't there a good chance that data from a previous question is still there? Yeah. So what do? Just hit delete until they go away. Bit like rubbing them out one at a time. Now I'm ready to start. The group I had was, well, the top one was a 65, 66, a 67, followed by a 68, a 70, a 71, and a 72. There we go. Type in the data. Once the data is in, so remind you how I did that. Start button, choice 1, edit, enter, type in the numbers. Once they're done, start button again, move over to calc, 1 variable stats. Now on my calculator, this is good to go. You just go enter, enter, enter. If you've got an older TI-84, you have to tell it that it's L1. And to tell it it's L1, you type in blue button 1. That's the only difference. So enter, enter, enter. And here we go. And the median is 68, which it was. And if I wanted to know the mean, it would be 68.42857 and so on. Any questions about that? You feel pretty good about mean, mode, and median so far? Okay, let's, well, I'll just skip through some questions just to show you what they look like, and then we'll see what the next, that's not what I wanted. Here we go. So here is your data set. Find the mean and median, either by hand or by the calculator. And well, it didn't take long to get to our next topic. Here is a table that contains summaries already created for you. It's called a 5-figure summary. And the numbers are a median of 171, an extreme of 131 and 250, and guys called quartiles, which are 156 and 205. And we are going to use them to find all sorts of other things. But let me just jump out of here and just take that data and show you all sorts of things you can get from it. This is called a 5-figure summary. So let's say the median is 171. We have guys called quartiles. There's always 2 of those, 156, 205. And then you've got guys called extremes. And they are 131 and 250. And I'll try and put in, yeah, it kind of looks like that, right? That's what the table looks like. Right. So I want you to imagine here that these numbers represent in thousands the value of houses in a particular area. So the median price of a house in this area would be 171,000. So that's what the typical house would sell for. The extremes, well, the cheapest one sells at 131,000, and the most expensive one in this area was 250,000, 250. And then you've got these guys called quartiles, 156 and 205. Now, from this set of data, they don't need to, and very often they won't tell you what the original data size was. Was this from 50 houses or 500 houses? And in a way, you don't need to know it for the things that you can get from it. So I'm going to visualize this in a different way. I'm going to draw a number line. And right here, I'm going to do 170. And then I'm going to go 160, 150, 140. I need to go a little bit further. Okay, 130. And then going the other way, 180, 190, 200. I'm probably not going to make it. 180, 190, 200, 210, 220, and so on, right? Now, 171 is about there. That's your median. The extremes are 131. And way over here, if I've done the scale properly, I don't like that. I'm going to have to do it again. I'm just going to have to shrink things to make it work. So I need 130 to 2. I need 12. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There. Okay, so there's 130, there's 140, there's 150, 160, and all the other 10s all the way to the end. $250 at the end, right? So 131 is about here. 250 about here. 171 is about here. 156 is about here. 205 is about here. So these are the 5-figure summaries. What this essentially tells us is that from this number here to this number here, 25% of all the data is in that range. So roughly 25% of the houses in this area are from 131 to 170 to 156 in price. So I better put these numbers: 131, 156. Now from 156 to 171, which is the median, which is here, another 25% of the houses. And then over here at 205, there's another 25%. And lastly, from here to the end, there's the last 25%. So we have an idea, not just what the typical value is, which is a median, right? Can't I tell the cheapest, the most expensive? And I also split the data into 4 chunks. So for instance, I can tell you that the top 25% of houses sell in the range 205,000 to 250,000. I can tell you that the lowest 25% of houses, they sell in the range 131 to 156. So with this 5-figure summary, I can tell what's the typical score, 151. What's the most extreme, 131 to 250. How are the areas, how are they broken into little chunks of 25% of all the data? Well, 25% in this range, in that range, this one, and finally that one. We also can calculate a new guy, which is called the interquartile range. Now, the interquartile range doesn't tell you the typical guy. It's not a measure of center. The interquartile range is a measure of how spread out the data is. And you get it by taking what's called Q3 take away Q1. So let me introduce some names. This guy here is called the minimum number. This guy here is called the maximum. The guys that they call the quartiles, right? So this is minimum, this is maximum, this is a median. This guy is called Q1 and this guy is called Q3, first quartile, third quartile. So you want to find the interquartile range. You take 205, take away 156, and I believe in this case 51, and we call it AQR for short. So we are essentially saying that the middle 50% of all houses differ in value by only 51,000, right? So the big chunk in the middle, there's not an awful lot. So imagine that we had 2 distinct areas in town, and one of them was called Area A, and the other one is called Area B. In Area A, the median house price was 250,000, and in Area B, the median house price was 250. The interquartile range in Area A was 50,000, and the interquartile range in Area B was 100,000. If that's the only information I gave you about these 2 areas, I can make a pretty good assumption that although the typical average value in the 2 areas is the same, the fact that the interquartile range is much bigger in Area B as it is in Area A, isn't that telling me that there's a lot more variation on the price of a house in this area, right? Maybe the one in the middle is 250, but couldn't I get a 50,000 falling apart house or a 390 very expensive house as well, right? The spread, how spread out they are, is indicated by the interquartile range. Right, give me a, using the interquartile range again, let me give you a different summary. There are 2 players. One's called Don and one's called David. And I'm going to tell you that in a typical game of basketball, Don gets about 30 points, and so does David. And the interquartile range for Don is about 3 points, and interquartile range for David is 12 points. Which one of those two players is the most consistent? And I'm using that word very carefully. The most consistent player. Who tends to get 30 points pretty much all the time? Not an awful lot of variation, maybe 27, maybe 33, but pretty sure he's going to get 30 most of the time. Who would it be?
Dawn, right?
Don? Yeah. Smaller interquartile range means there's not an awful lot of variation in the numbers, right? The middle is 30 and everybody's close to 30. David, on the other hand, yeah, he gets 30, but couldn't he get a 42-point gamer, and couldn't he have a bummer of a game and get 18 points? Right, let's say he's your star player. Now, why does that matter? Well, imagine that you are the manager and you're playing the final game of the season, right? You want to win the cup, whatever it is. And you know that the team that you're playing, because you've played them tons and tons of times before, that team that you're playing tends to beat you more than you beat them, right? So you're the underdog. And you have a decision to make about whether you play Don as your star player or whether you play David. If you're playing a team that you get beat more often than not, you should pick David. And you might think, well, why? There's average is the same. Why should I pick someone who's inconsistent? If you play Don, aren't the chances are that he's going to get you 30 points, maybe 33 on a good day, maybe 27 on a bad day. But that's not enough to beat the other team, right? 3 points is just more than you need, right? If you play David, couldn't he have a horrible day and only get you 18 points? In which case you're going to get beat. But weren't you probably going to get beat anyway? But if he played a great game, couldn't you get 42 points out of him? And couldn't that you win you the day? So can you see that consistency can be used in a way to decide who to play? Now, if you're playing a team that you know you pretty much guarantee to win, wouldn't you pick Don? Because you want to play safe, don't you? You don't want to have a guy with a bad day. So you pick him. So it depends on circumstance, what that would be like. Any questions about that? Interquartile range is a measure of how spread out, how inconsistent the data is. Okay, let's return back. Oh, chat, that might mean I have a question I should look at. Yeah, some people in the class agreed with you. They said it was done, which is good. So let's return back to the homework and see where that leads to. Right, so in this question here, 63 college men were asked what they thought was their ideal weight. And this is a 5-figure summary. So they didn't ask them what their weight was, but what weight they would like to be, right? And the median was about 171, and here are all the choices. So find the value of the range of this data. Now, I haven't talked about range yet, so let's do that one. I've talked about interquartile range, which is B, but not A. The range is the difference between the two extremes. So if you take 131 away from that guy, I believe you're left with 119. There's your range. Now, what about the interquartile range? Well, in the interquartile range, don't you subtract those two guys, Q3 and Q1? Excuse me. In this case, you get 51. And then it says about what percentage of the main responded in the interval 131 to 205. So let's see where that is. 131 was the smallest and 205 was the biggest. Oh, that's a cheat question. That's an easy question. A trick question. What percentage of people gave an answer between 131 and 2? Oh, I misread it. I thought that said 205, in which case the answer would have been 100%, but it's 131 to 205. And that's going to be done by using that diagram I created earlier. We want to know what percentage of people from 131, which is here, all the way to 205, which is here. Now, if you look at that, isn't it 1, 2, 3, 25%ers? 25% of the data from the minimal to Q1, 25% to the median, 25% to Q3. 1, 2, 3 of them. So the answer would be 75%. Are you okay about how I calculated that from there to there is going to be 75% of the data, and that bit there's what's that? Are you okay with that? Okay, then let's check it out. Here are the answers. I'm going to go submit answer. And I want to see nice little tick marks. Ooh, I can't subtract. Find the value of the quarter range. That is the value of the quarter range.
It's 49.
Oh, I can't subtract. Thank you. Well, moral of that story is shouldn't you use calculators? So let's try it again. Submit answer. There we go. So let's continue with the, only time for one more topic and I'll call it a day. So got windows to close and windows to open. I want you to imagine that I have a 5-figure summary again. I'm going to write it down a little bit differently. I'm going to write it as the minimum was 5. Q1 would be 7. The median is 10. Q3 is say 15. And the maximum is, let's say, 30. Now you might see it in your homework written more like this, you know, where they would do 7 and 15 here, and the extremes would be 5 and 30, and the median would be up here. So I'm just basically taking that data and like writing it down a little bit more in a linear fashion. Now, there is a very interesting diagram we can create called a box plot. Now, to create a box plot, you basically use the 5-figure summary. And you look for the smallest number, which is 5, and the biggest number, which is 30. And that allows you to say, okay, I'm going to start at 5, 10, 15, 20, 25, 30. And if I need a few more, I can put them in. It's okay to have extra, right? Now, the minimum is at 5. Oh, I better put some other numbers in here. 10, 15, 20, 25, and 30. And you put in 5, you make a little mark there. And maximum of 30, you put a little guy there. Q1 is 7, which is about here, you make a longer line. the median is 10, you do that, and Q3 is 15, you do that, and then you join the big lines together, and then you join these little guys to the end, and that's called a box plot. And there are your 5 figures, and it's a very nice visual way to represent the data. There is a problem, and it is with the extremes. One of the difficulties with a 5-figure summary is that you can sometimes get distorted in view of what the data is telling you if you have one extremely big or extremely small value. These are called outliers. An outlier is a data point that is extremely different. I don't know if I want to use the word extreme. Is exceptional, that's fair. It's exceptionally large or small compared to the rest of the data. Well, if you look at the two extremes here, 30 might be an outlier, 5 might be an outlier. So how do we test for outliers? Well, we create two numbers. One's called the lower fence, and the other one is called the upper fence. And what these two numbers do is they put a boundary on where the good guys are and where the extremely big or small, where the outliers live. Now, the formula for the lower fence is Q1 take away 1.5 the interquartile range. So in my data here, the interquartile range is Q3 take away Q1, which is 15 take away 7, so it's 8. So Q1 would be 7 take away 1.5 times 8, which is 7 take away 12, which is -5. I love this guy. So you would need to be smaller than -5 to be an outlier. So can you imagine that this was representing temperatures? So you'd have to be really cold. Now, if you want to do an upper fence, the formula is Q3, not Q1, and add, not subtract, 1.5 interquartile range. And Q3 is 15, and it's 1.5 times 8, and that would be 15 times 12, and that would be 27. And you would need to be bigger than 27 to be an outlier. Now, is 5 going to be an outlier? No, it's not smaller than the fence. Is 30 going to be an outlier? Yes, it's bigger than 27. So what do outliers look like when you do your box plot? Well, your box plot will look like that. This guy up here, can you imagine him being the 30 or whatever it might be? You put a little star there, and then you draw your box plot starting, at 0 and doing all the other numbers. Sometimes you do it like this. sometimes you draw your box plot with all the other numbers, and then you just put a little note saying 30 is an outlier. Now, the reason why you might have to do it the second way instead of the first way is, can you imagine in a different world, the box plot looks like that and the outliers like that? Would you agree that there's virtually nothing to see here because everything is crunched? Wouldn't it be better to write that picture and then just say, oh, 300 is an outlier, whatever it might be? And that has pretty much taken us 10. So what I want you to do now, guys, is to write down just your last name into the chat, and I will be using that for attendance. So if you could, put in whatever it is. Okay, we are good to go. I shall probably see you tomorrow. I'll send out the link because I don't think I'll be up for tomorrow, but who knows? I'll tell you tonight what it's going to be, but my guesstimate is I won't be perfectly ready by tomorrow. But Wednesday is a good chance, the way I feel right now at least. Anybody who's got any other questions, hang around. Otherwise, bye-bye for now, and I will see you when I see you. Tomorrow, probably, on Zoom. Hi, James, you got a question for me?
No, sir. I just couldn't figure out how to leave.
Oh, close the top right-hand X is probably the easiest way to do it.
Oh,
Is there a little X up there?
yeah, I got
Or
it.
a
Thank you,
leave
sir.
meeting or whatever. Okay. Okay.
Have a
Anybody
good day,
who
sir.
you too, James. Anybody that's here got a question, or are you just taking time to leave? Anybody? Oh, they might be in chat. Let me check. Robert or Hadley? Either you two good questions. Hadley, the project one is a project that was due on today. So I guess you've got until today to get it done, but you can, well, you've got to get it done and hand it to me when I come back. So it's basically some questions that, well, you don't get a project one. Forget that. Stats doesn't have a project one. There is no project one. Why? Did I mention it somewhere? Because my other classes do have one, but I never mentioned it for you. Okay, let me go hunting for that and remove it because it shouldn't be there. So, are you in 146, Adler? Hadley, are you on 146? Okay, so anything that mentions Project One, pretend it never mentioned it. It doesn't exist. It's not something you need to worry about. All my other classes have a Project One, which is probably where the confusion arose, but not my 146 class. So your life is a lot easier. One less thing to worry about. Oh, can you tell me before you go, where did you see it so I can find it to rub it out? Under modules and assignments. Modules, assignments. Okay, let me find out what assignments look like. Oh, I see it. Yeah. Okay. I can take care of that right now. That's it. It's done. It's not there anymore. Thank you. Bye-bye. Robert, do you have anything to ask me, or are you out of here too?